Alright, 8th grade honors class, we're going to go over square roots and pythag. That's Pythagorean theorem for you. Alright, let's do this. Square roots, you already know what a square root is, but let's do another review. What is the square root? Or what is the root of a square? It's what defines a square. So the square is defined by its sides and by the angles inside. All the angles inside have to be 90-degree angles. And then all the sides have to be equal. So all these sides have to be equal. So a square is defined not only by its angles, but mainly by its sides being equal. That's what separates it from being a rectangle. Alright, so the root of a square are the sides. So this is where square root comes from. When you have the square root of 4, it's asking you, what is the root of the square with an area of 4? This represents area. So, if the sides are the roots, it's really asking, what are the sides of a square that has an area of 4? So, that's 2, because 2 times 2 is 4. Perfect square is when you get a whole number as a root of a square. So like, these are our favorite ones because they're easy. Square root of 25 is 5. That's a whole number. Square root of 9 is 3. Square root of 16 is 4. Square root of 121 is 11. Something that would not be an example would be like the square root of 421 or the square root of 5. We don't know those, so what do? We estimate. Sorry about that, it's flipping out. So we estimate. So estimating roots. Let's start with 5 because it's easier. To estimate a root, this is what you're doing. You're trying to figure out what two numbers is it between. So what two numbers do the sides have to be for the area to be 5? Well, it can't be a whole number because it's not a perfect square. So let's figure it out. If the area was 4, then the sides would be 2. So the square root of 4, the sides would be 2. If we did the square root of 9, the sides would be 3, which is the next whole number. Now what we want to do is we know that it's between 2 and 3. It's somewhere in between here. We just don't know where. So I'm going to go ahead and put this down. I'm going to go ahead and put 2 point something. That's what we're trying to figure out. So what do we do now is we establish a halfway point. How far is 9? Well, what's the halfway point between 4 and 9? Well, there's 5-point differences between 4 and 9 because 9 minus 4 is 5. Half of 5 is 2.5. So really, right in half of these two numbers right here would be 6.5. Now, here's something we can already see. Is 5 on this side of 6.5 or is it on this side? It's on this side. So we know it's got to be below 2.5. So how do we actually get really close to figuring it out? This is how. The difference between 5 and 4 is 1 difference. Let me use a different color. It's a 1 difference. The difference between 5 and 9 is a 4 difference. So it's extremely close to 2. So if I was going to estimate, I would estimate at 2.1. I might put 2.2 and I'm not wrong because I'm estimating. But it's probably more likely going to be 2.15 or 8 or something like that. Let's do 421. It's a little bit harder. Well, we know that 20 times 20 is 400, so square root of 400 is 20. And so the next whole number would be 21. So 21 times 21 is 441. Let's try that out, just to make sure. 1, 2, 2, 4. So 441, we're right. Alright, so we've got this. Now, where is 421 in this? Let's find the halfway point. Well, we automatically know it has to be 20 point something, so let's go ahead and put that down. The halfway point between 441 would be about 20.5. 420.5. If this is this on the right side or left side of that? It's on the right side. So it's going to be above 2.5. In fact, it's really close to this. So I would probably put 20.6. Now, do not put 20.5 because we know what the halfway mark is. If you think that it's still 20.5 something, then what I would do would be 20.58. But don't leave it at 20.5 because that's automatically wrong. Let's go from here. Pythagorean theorem. This is our next big lesson. I'm going to briefly go over it because we're going to do some things in class that's going to show it more. Plus, you've already had it. Pythagorean theorem is a squared plus b squared equals c squared. And these are sides. These are sides of a square. So really, if you think about it, these are areas. Area of a square A plus the area of a square B equals the area of a square C. It's really what it is. We're just adding the areas of 3 squares together. Now, we have to be able to manipulate this problem to find C, find B, find A sometimes. So let me show you how that's done real fast. Let's go for C. Well, C, it's already pretty much solved for C squared. So how do I get rid of the C squared? Well, C squared is C times C. So the only thing that I know of that would get rid of this, and remember, this is actually the area of a square, and we're trying to find C, which is be the side of the square. So if I'm trying to find the side of the square, I'm going to take the square root. So the first thing I'm going to do is take the square root on both sides. When I take the square root, I am going to get side C. Now the left side is going to stay like this because we can't do anything yet. We don't know what A and B are. But now we have a formula for C. It was the easiest one. It's A squared plus B squared. Alright, now let's solve for B. Well, here's B. Remember solving equations? To get B by itself, I have to get A and put it over here. Mathematically, that's not possible. Just to throw it over there. There's a process to it. And here's a process. I'm going to subtract A squared from this side. The reason why I'm going to do that is because A squared minus A squared, when we collect like terms, turns into 0. It goes away. So B squared equals. Now the only thing is, if I do it to this side, I have to do it to the other side. So I'm going to minus A squared over here. So I end up getting C squared minus A squared. So let me rewrite this. B squared equals C squared minus A squared. Now, how did we find C? We had to take the square root of B squared. And you end up getting the square root of C squared minus A squared. And guess what? Ends up being the same thing for A. The only difference is the A switches with the B. Now here's a box. This is what it's doing. This area, which is C, and this area, which is A and B, or B and A, it really doesn't matter because they're both legs. A lot of people argue that this is B because it's the base, but if it's turned sideways, then it's no longer the base. So we're adding A plus B equals C to find the sides, like this. And that's what we're going for. Now this looks really confusing, but it'll make more sense when you get in class tomorrow. So as of right now, let's just say and I'll see y'all in class tomorrow or Monday. Bye-bye.